Now we come to next lecture 11, 11A, 11B we will see torque converter with direct drive. In 11A we will study the torque converter. Let's first read it. The torque converter, as the name suggests, torque converter is a device which performs a function similar to gearbox, namely to increase the torque while reducing the speed. We saw that in the previous lectures. What is the function of the gearbox? Because of the gear, number of teeth on the gear, the torque is increased and the speed is reduced. Engine speed is very high, we had noticed, and it has to be brought down to the wheels where the speed is slower. So it's doing the same function what a gearbox does. But whereas the gearbox provides only a small number of fixed ratios. Small number means gear number 1, gear number 2, gear number 3, 3 or 4 forward, 1 reverse or 2 reverse. That's all. Here they are infinite number. But whereas gearbox provides only a small number of fixed ratios, the torque converter provides a continuous variation of ratios from lowest to highest. The lowest to, let's say from gear 1 to gear 4, there will be a number of continuous variation of ratios. Uncountable, you can say, infinite number you could also say, from lowest to highest. So let us see the construction. The torque converter consists of 3 elements: pump, turbine and stator. In the flywheel, in the fluid flywheel, which we had studied in lecture 5, there were only 2 elements. Here there are 3. You can go back and revise that, lecture 5, see. And that's why in fluid flywheel, there was no variation possible of torque. This has been provided due to this particular stator. Pump, turbine and stator. Now let us see the construction. The pump is connected to the converter housing. This is the pump. Connected to the converter housing. And the converter housing is bolted to the flywheel. And as we know, the flywheel, after the crankshaft comes the flywheel. This is bolted. So when the engine runs, when you put on the engine, the crankshaft will rotate. Whatever I showed you, the pump section, this will start turning when the engine is put on. Second element is a turbine. From the pump, the fluid directs into the turbine. We will see exactly how. And from the turbine, the stator is the one which provides the torque, various torques. And the turbine is connected to the transmission input. That means this is connected to the propeller shaft. The turbine is connected to, this is all the turbine, is connected to the transmission input shaft going on to the propeller shaft. The stator, in between the stator and the transmission case, there is a one-way clutch. One-way clutch means it allows the stator to revolve in only one direction, which is the direction of these two, and not in the other direction. Direction of oil flow is shown. One-way clutch. So let's read this. This is the construction. Hope it's clear. Somewhat similar to fluid flywheel, lecture 5, but differs in having 3 components instead of 2, as mentioned. It is a donut-shaped device, approximately 25 centimeter to 40 centimeter in diameter. Donut, you know, there is a hole inside, round with a hole inside. That is donut. that is mounted between the engine and transmission. Between the engine and transmission. This is between the engine. Crankshaft means engine and the transmission. This consists of three elements that work together. All three work together to transmit power to the transmission. These are the pump, turbine and stator. Pump is mounted to the torque converter housing, as I showed you, which in turn is bolted directly to engine crankshaft and turns at the engine speed. When you put on the engine, it will turn. Turbine is inside the housing and connected to the input shaft of transmission, providing power to move the vehicle. Stator is mounted to a one-way clutch which allows it to spin freely in one direction only. All three elements have fins to precisely direct the flow of oil through the torque converter. Now this angle of fins itself is a big study. The angle of the fins allowing the fluid to pass through and going through. The angle and the shape and the construction of the fins is of paramount importance in this torque converter. With engine running, the transmission fluid is pulled into the pump element, and it directs the fluid into the turbine. Here it rotates circular fashion and then comes to the center. It is pulled inward and is pushed outward, pump element, and is pushed outward by centrifugal force. As you can see, by centrifugal force. All three elements are fin to direct flow of oil through with engine running, the transmission fluid is pulled into the pump element and is pushed outward by centrifugal force. Rotating is high-speed, natural centrifugal force comes into play, and that centrifugal force will push the fluid into the turbine. The fluid continues in a circular motion back to the center of the turbine, where it enters the stator. Now, if the turbine is moving at a speed lower than the pump, then the stator, the front fins, will not prevent the fluid to go in. Is moving slower than the pump, the fluid will make contact with the front of stator fins, which push the stator into the one way. When this is running less than this, the stator is pushed into contact with this one-way clutch and prevents it from turning. The clutch grips the stator and does not allow it to rotate till the fluid pressure builds up. Fluid will make contact with front of the fins, which will push the stator into one-way clutch and prevents it from turning. With the stator stopped, the fluid is directed by the stator fins to re-enter the pump. At a helping angle. That is, the angle of these fins are important, and it directs the fluid back into the pump, providing a torque increase. Means torque increase is gradually the torque will go on increasing. Initially, some fluid, as the pressure builds up, rotation, centrifugal force, the fluid is pumped back into the pump at increasing velocity and increasing pressure. As the speed of turbine catches up, so this it's gradually increasing as the speed of the turbine catches up with the pump. Pump is supplying initially to, as I said, from transmission fluid is from the pump to the turbine. In the pump, the fluid starts hitting the stator blade on the backside, causing the stator to turn in the same direction till such time pressure is built up, the stator stops it, only sends the fluid here. As the speed increases, then the back plates of the stator, they start turning in the same direction of the pump and turbine, and gradually, as the speed increases, all three will attain the same speed, begin to turn at approximately the same speed, and clutch gets disengaged and the transmission input shaft, the power will flow this way. So they all three work in tandem. Initially the pump to the turbine, stator has got a big role. This is the one which increases the torque, gradually increases or decreases depending upon the driver what he wants. Now in the next lecture we will see the torque converter with direct drive as per your syllabus. What happens when you connect the torque converter with the direct drive. Okay, thank you.